Hello everyone. In this video, we are going to look at what are generics, when to use them, why to use them, and we'll look at the differences between empty interface and generics. And in the end, we'll look at a generic implementation of a stack data structure. So what are generics? Generics allow us to use a piece of code for more than one type while providing type safety. So in essence, it lets us parameterize types. What do I mean by that? When we started learning how to code, most of us studied or first came across functions as a way to abstract away logic so that it could be used somewhere else provided the parameters that the function operates upon are of a certain type and the return object from the function is also of a certain type as well. So it made our code reusable and abstracted away certain logic. But what if we wanted to use these functions on more than one type? How do we go about doing this? Well, in some cases, we might be better off making more than one function which handles different types differently. But in many cases, if we define separate functions, we'd be repeating logic which can be written only once. In the world without generics, we can solve this problem using an empty interface. But to be safe from a panic, we'd have to make sure that the arguments passed to this function are compatible with the plus symbol in this function. And on top of that, we'd have to use type assertions on the returned value before we use it in our program. This is not an ideal scenario, but we can make it work. But what if we could pass a type itself as a parameter to the function? This function could then work with the passed type and return results of that same type. Well, this is exactly what generics allow us to do. It essentially lets us parameterize the type like this. Here, we are essentially saying that, hey, define a function add that accepts two values of type t and returns a value of type t, where t can be any of type int or float64. Notice how the type is also sort of a parameter to the function. We can also skip this parameter when calling the add function because the compiler is smart enough to infer it from the passed variables. So when to use generics? When you have functions or data structures that perform the same operations on different types. We have already seen example of such a function in form of the add function. Let's look at an example of a data structure. We'll create a generic stack that can store any type of data. This stack will be able to handle strings, integers, floats, and any other type while performing the basic stack operations of push and pop. For that, we'll first define a generic struct name stack which can work with any type t. The stack has an elements array of type t. Now, when we initialize the stack, we provide the type that it can take or it should take like this. We define the push function like this, where type of s is a pointer to the stack which takes an element of type t. The push function takes an element of type t and we append it at the end of the elements array which we defined earlier. Now this push function is not dependent on any particular type like int or float64. It just expects that the type t of the element passed is the same as the one which is used by the stack. When we use this function to push elements in the stack, notice how we can change the type of elements based on what the type the stack accepts. Similarly, we can also define the pop function where we return the last element if it exists. We are using the value error pattern here, where if we can pop an element from the stack, we return true as the second value, and if no elements exist in the stack, then we return nothing and return false as the second value. The code for this stack is flexible as it allows for us to use different types with the same code while allowing type safety at the same time. But why even use generics? We'll take a look at these two pieces of code. In one, we have written two functions to do the same task on two different types, while in the other, we are doing the same thing but we have only written the logic at one place. Now, in the future, if we ever had to change the logic of the add function, we'd have to change in two places for this part, but only at one place for this part. So the code with generics is pretty easy to maintain. Generics give a boost to the performance as well when we compare similar implementations using empty interfaces. Because when we store values of any type in an empty interface, we lose the concrete type information. Also, to perform operations on variable returned as empty interface types, we need to perform type assertions which introduce runtime overhead. Reflection may be used when working with interface, which is slower due to dynamic type inspection. While when we use generics, the type information is preserved at compile time. The compiler generates specific code for each instance of the type, eliminating the need for type assertions on reflection. So operations on generic types are as efficient as operations on concrete types. But there is one thing that cannot be done using generics and can only be done using an empty interface, which is we cannot make a collection like this. Notice that we are using different types in the same array, which is not possible without an empty interface in Go. We can do this because all types in Go implement the empty interface so that they can be packed or unpacked using an empty interface. So that is it for today, guys. Please like the video if you learned something and subscribe to keep learning. Thank you.